For the past 50 years, the world economy has run almost on fossil fuels. While fossil fuels provide us the power to drive our economies, they also release billions of tons of carbon dioxide into the environment.
Carbon dioxide is assigned as one of the greenhouse gas. According to US EPA 2017, more than 80% of the greenhouse gas detected in the environment is carbon dioxide. Besides the burning of the fossil fuel, carbon dioxide can be found in a big portion in the natural gas. So is this required to be removed before the further processes? By the industrial basis, three effective techniques are required to separate carbon dioxide, either by the sorbent or solvent, by the membrane, or by the cryogenic distillation.
When flue gas containing CO2 gets in direct contact with amine.
In the absorber process, the flue gas flows upwards and meets a liquid containing water and amines, which will absorb the CO2 from the flue gas.
At the top of the absorber tower, flue gas runs through the final emission control system, while the amine liquid, now containing CO2, is routed to the desorber system, where the liquid is heated up to about 120 degrees Celsius.
Well, absorption by the base solvent is quite promising method. Amine's coupling technology was established more than 60 years ago. This is under oil and chemical industry. This is to remove hydrogen sulfide and carbon dioxide simultaneously from the gas stream. As you can see, the carbon dioxide capture also requires some energy in the regeneration part. So the objective of my design project here is to evaluate what type of this amine solution to be used under the criteria of energy conservation and economics.